And we're live. Hello, hello. Welcome to my very first recreational programming stream. And I got into it from watching a guy named Soding, which you'll find a link to his streams in the description. But what he does is he just does kind of things, programming things for fun, um, on a daily basis almost. And I kind of want to do the same thing because I enjoy programming. And maybe there's others that would find what I'm doing interesting. So today, I'm going to be working on a brainfuck interpreter in Crystal. I've never used brainfuck and I've never used Crystal either. I've heard of them and I've been a fan. I've been sort of like watching the development of Crystal for a while, the programming language, and I thought this would be a good opportunity to just kind of learn it and also just kind of do something fun with it. Yeah, so I haven't downloaded anything yet. The whole point of these kind of things is just kind of start things from scratch almost, or just kind of like learn like on the stream as well, just kind of as we go together, and hopefully we can just do fun things. So let's get started here. I'm just gonna go ahead and move a window here, and let's just get started with, I guess the first thing we should do is probably learn brainfuck a little. Like let's do like just do a hello world program in brainfuck. If you haven't heard of brainfuck, it's like a very esoteric language, and the reason it's called that way is just because if you look at any program written, it just kind of almost looks like gibberish. It's really hard to tell like kind of what's going on. But because it's so, easy, so like kind of cryptic, it's also incredibly easy to parse. Like you don't really care about identifiers, you don't care too much about operations. You can do everything with just these 8 instructions, which is like pretty interesting, pretty cool, but also kind of deadly. So the idea is that you have this like data pointer. I'm not sure. Okay, yeah, so it's bytes. So you have like this data pointer, sort of like you have this long array, and it starts off at the 0 index, and then you have these instructions here to move it forward on that index, and then you have this instruction here to move it back, and then you have one instruction to increment whatever's in that data, whatever index you're on, it increments that number by 1 with using this the plus symbol. You have this minus symbol. This is the same thing, just minus whatever's in the data pointer by 1. Here's your print function, it's a dot. Here is the input functions to accept 1 byte of data. And then you have like these things that could act as like a for loop, an if statement. These are jump instructions pretty much. And this one here, basically, this one jumps to this instruction here. So the matching brace if the data pointer is at 0. And this one moves back to the matching opening brace if the data point is, what is it, non-zero. So it's just what it says here. I've never written in this language. I have heard of it and I have seen it a few times. I've seen Hello World a couple times, but I obviously do not remember. I don't remember any of this, so we're just going to be doing that just on the spot. So the first thing I want to do is, I guess, get the compiler for it. Okay. So the first thing I want to do is I just kind of want to like print something on the screen. So I guess since everything's in bytes, I have to look up the ASCII code for, I want to just maybe do like print A. Okay, so capital A is going to be 101, I guess. Or nope, the decimal is going to be 65. Okay, so from what I understand, we only have the plus and minus. We only can like increment data pointers by 1, and so we're gonna have to do like either 65 pluses to get to that A, or we can do like some multiplication in brainfuck. But for now, I'm just gonna type in literally 65 pluses, and then I'm just gonna try to print it. So that's 5 of them here. That is 60, and then 1, 2, 3, 4, 5, and then dot. And that should print A. Okay, perfect. That's all I wanted to see. That's like a sort of like a sanity check. And then if we wanted to do hello world, we just have to, do whatever is the ASCII code for E. So that would be 69. So we can go, nice, 69. So we can do 1, 2, 3, 4, and then print that. That should do HE or AE. If you want to do hello, we'd go through that. But so I kind of just want to get down to coding the Crystal interpreter. So, or yeah, the interpreter for brainfuck using Crystal. So let's go to Crystal's website. Okay, so I guess guess that's all we need. So the terminal, and wish me luck. Curl's not found. Can't believe I don't have curl or CURL. Let's install that. Go. Try once again to get crystal. Oh no, it's done already. Okay, cool. So that's done. See, how do we even write a program? I haven't used crystal. I've just seen kind of like how the code kind of looks like, and it looked interesting to me. Okay. Oh, it's that easy. I like that it's this easy. Let's open up. I like using Vim, so I'm just gonna use NeoVim to create a new like to just edit my code. I'm not going to use anything much more complicated than that. I feel like it should, like this program should be simple enough that I don't need any type of IDE for it. So, and I kind of want to like coding in simple things. So, what was I going to do? All right, make a folder here. Let's call this interpreter. Cool. And we'll just go in there. Sweet. And man, I wish I could somehow get rid of this here, but I'll just make it a little smaller. There you go. Okay. Now, what was I gonna do? I'm gonna write my hello world program. So let's go into NeoVim. Hello. Cool. And I think what they did was just this. I don't think I need semicolon at the end like C. So I think that's pretty much it. And I guess we can now run it. Nice. We got Hello World in Crystal. I want to know how to build. I'm not sure if this is compiling, and I know Crystal is a compiled language. So what does the executable say? Build an executable. Okay. Maybe if I just do this, it'll work. Maybe. Nice. And then can I run it? Cool. I really like that the build system is that. Well, I know that's not the build system. I think they have like this shard system for libraries and stuff. But it's really cool they have like a very simple way of like just doing a compile. All right. Let's get started. Cool. And I guess the first thing I want to do is learn how to put stuff in a list, or I guess make a function. I just want to make a function that use def. Okay, so it's like very similar to like Ruby. Main, and yep, I was about to put braces there, and then I guess we can also do just to do another check here. So that should feel like this should just work. And that should just print hello world. Perfect. Cool. Crystal's cool. So I guess one of the first things I want to do is figure out how to make lists, how to make arrays. Cool. So it's just very simple. All right. For now, I'm just gonna hard code some instructions, and I guess it would make sense to write like a hello world in Brainfuck just to test it. But for now, I'm just gonna go and test. For now, I'm just gonna test like the program that prints A, because I feel like that's like the hello world version of Brainfuck. And so if I remember correctly, I think it was 1, 2, 3, 4. Oops, no, it was move that data pointer to the first cell, how I did it before, and then have I think 13 pluses, so that's 4, 5, 1, 2, 3, 4, 5. Then we open up a loop. We move the data pointer back, and we add 13. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. We move the data pointer back forward, and we minus 1, and then we repeat that loop, and then we print A. Okay. Let me copy and paste that. That should just print A. Nope. What did I do wrong? Oh, I keep forgetting that I have to move this back. Perfect. There we go. Okay, because this is pointing. By the time this leaves the loop, it's pointing at the first index, not the 0th index. Okay, so that's our A program. And let's put that guy in here. So this is going to be our, you see like there I just pressed Control V and that happened. But this is going to be our hello world program. And I think in Crystal you can just do that. And if we should just be able to, I should be able to just print it. Oops, where is it? It's program. Undefined local variable or method program for top level. What does that mean? Can I comment like this? Does this work? Well, that does work. So there's a difference between global variables and local variables, where you have to do something extra to get the value from a global variable. So maybe instead of having this out here, I can just put it inside of main, which should be just fine. I'm not going to worry too much about the specifics of it. So let's see if that works. Nice. And okay, cool. So that's going to be what we are parsing. So let's go back. And now all I need is a way to all I really need to do is iterate through these, create one big long byte array, and that's kind of it, honestly. And we're just gonna see if this works. Length, undefined method length. Okay, so maybe it's size. And no, I'll try count. Nice. You can just sort of guess things in programming. 26. Okay, that seems correct to me. Oops, I didn't mean to do that. Yep, this seems like 26, right? 1, 2, 25, 26. Perfect. Okay, so how do I do, like, I just want to know how to do, like, a count. Like, how does the Crystal expect me to, like, count up, pretty much? That's all I want to know. While. Like, how do I do, oh, there's a loop. I guess they really want you to, like, place it outside. Which is fine, I guess. Okay, that's fine to me. That's fine. Index is 0, while index is less than program size. Yep. And what we also need is we need a way to I guess here's something else we could do. It'd be cool if in C, because in C we have like literally like a pointer. We can use pointer arithmetic to move sorry, my thing fell off. We can use pointer arithmetic to move like the data pointer up and down. But in Crystal, I'm not sure if there's such thing as pointer arithmetic. So I guess this doesn't seem like this Crystal is garbage collected. It just doesn't seem like the Crystal way of doing things is using pointer arithmetic. So I'm not. Okay. All right. So that's we can just say this is like the instruction pointer. Literally, because, and we could pretty much just do this all in line. Like, it's really that simple of a program. So I'm gonna keep this as yeah, let's call this data pointer just to make it like or DP. Oops. DP. Let's make this a data pointer, or actually no, let's make this the IP, which is the instruction pointer. And then we need a data pointer, and that will be like for an array that we'll set up here. So let's just set up that array. Let's set up an array of like is there a way to reserve array size? New size value. Perfect. Here you go. That's what I wanted. So this is going to be the data, and that's going to be an array of, I hope I can just type byte in there. I'm gonna type byte in with capital B, so I feel like that should be possible. And the size is gonna be, I think we'll go for 1000, and it'll all hold zeros for now. Okay. I also just want to see what happens if I just put S on data. Okay, so let's see what it prints if I do that. Undefined constant bytes. Did I mean bytes? No, I meant byte. Okay, let's see the types then. Let's see what Crystal let's see the types in Crystal. I think Crystal does not have literals. I don't think Crystal has bytes. I think it just has integers. Okay, there's uint8. I think uint8 is the way to go. So let's do uint8. Build. All right, let's go. And what does it print? Oh shit. This is 1,000 zeros? Doesn't seem like 1,000 zeros. So that's working fine. This is the data pointer, so it's going to point to the first index of the array. I guess it's just how it starts. And then we also need, I think that's it actually. I think this is literally the entire like backend setup for Brainfu. So let's write the program now. I'm pretty sure we can sort of just move. Yeah, we can just move within like this like loop. So when we encounter like this, we can just quickly just like look for the other one. There's no reason to like pre-process this. We encounter this, it's 0, and if it is, then let's look for the matching brace. And same thing here. If we encounter a closing brace, then we simply just move back to figure out where like it should loop to. So let's do that. Is there a way to do switch cases in Crystal? Okay, cool. So they have this case. Yeah, they have this case thing. Cool, let's do that. Let's use whatever Crystal wants us to use. So case on program. Actually, let's take the opcode out. Program index, and we're gonna do OP here, and I think this has an end, right? Yeah, it has an end. And here we can just check for when. Do I use this? I'm not sure. Okay, how about we simply, is there a way to do defaults? Else. So let's do when dot. Then we want to hello world, and then for everything else, by world. And I think that's it. I think else, that just ends it. Okay, so actually, this is way too long. So let's make this 0, and then let's make this 1. So this is just to see if it's working. This should really only print 1 up until the end. Like in I guess it doesn't put like new lines. So I guess we'll find out. I guess we'll find out how this prints right now. Index, local variable index for top level undefined local variable. Index. Oh, it's because I called it IP. IP and IP. Cool. And oh right, you know what we forgot to do? We forgot to increment the pointer. Does this work in Crystal, or do I have to do? We'll find out. We can always just try stuff. It even tells you you're not supposed to use the postfix, is not the incrementer. Okay, so we'll just do this. That's totally fine with me. And we'll build here, and this would just print 1 and then 0 at the end. Yeah, that makes sense. Cool. Cool. Is there a way to print without the new line? Alright, well, I'm not going to worry about it too much. I'll look it up later. For now, let's just get a quick interpreter working. Because it's taken long enough to do that. Okay. So when we see... So this seems to work just fine. When we see a dot, print... when we do that, we're just going to put S on wherever we are in the data array. So whatever that is, we're just going to print it. What else do we have? This is the data pointer instruction to increment the data pointer. So for this, all we're going to do is that. That's really all we need to do. This one's a decrement, so we're gonna do that. Oops. What else do we have? We have a plus. So with that, we can just do data pointer, and we're gonna do a +1 here. It's really, it is really this simple. Okay. Okay. What else do we need to do? We need to add this loop. So this, it's really just these two instructions that will be the harder ones to implement. This is 1, 2, 3, 4, 5. And after we add these two. Well, what was the other instructions we need? We need the dot, which we have. We need this one and that one, which we have, and then we need the comma. So now let's implement this guy. So this one's a little bit interesting because we actually have to move to the next. We have to move to the next bracket, the closing bracket, if the data pointer is at 0. So actually, because we have to control the instruction pointer ourselves, we can just put these. We're gonna have to. We'll put these everywhere. Oops. Oh my god, everything's going crazy. Oh god. Everything's broken. Oops, that was just me. I accidentally closed this too quickly. And it didn't save. Nice. That's great. Now let's do the loops. So this one's going to be interesting because we need to actually modify the instruction pointer, but only if the data pointer is, I think it's 0, right? If it's 0, then it should skip over it really should skip over until the next bracket should skip over everything. Data point is 0, then instead of moving to the instruction pointer, next command, jump forward after the matching. So it's after. Okay, that's important to know. So we have to find this and then move the instruction pointer 1 past it. So it doesn't, there's no repeat of like checking. It's non-zero, but I don't think it would matter because this one only moves back to the matching opening brace if it's a non-zero. And since this only jumps everything if it's 0, then even if it did hit this, it would just keep going because it's a 0 and it only moves back if it's non-zero. Okay. So for this, we actually just have to find the next matching closing brace. And for that, we actually need to keep track of all the open brackets. And so for right now, there's one open bracket. And when we find the next open bracket, we have to add 1 to our open brackets list because the matching closing bracket is going to be the one after all the open brackets have been closed. Because it just could be something like this, right? There could be something like this, and then this bracket closes with this one. And so if we want to skip everything, we need to make sure to keep track of all the open ones and all the not open ones. So yeah. All right, so we're gonna keep this going while the bracket is greater than 0, and to do that, and we're also not gonna do error checking at the moment. If like we're gonna sort of assume that like all the matching braces are there, and we'll do error checking later, maybe in the next stream. But for now, we're just gonna get a Brainfuck interpreter working, and then that'll be the first stream, and that'll be what we're doing. Next time we'll add error checking, and hopefully I'll get into native compiling. Okay, so while those brackets are greater than 0, we're going to keep incrementing the instruction pointer. And actually, we should check. Actually, do we even need to? No, we will. We'll do it this way. So first, we're going to check, or up here, we're going to actually move it. Oh, okay, I understand it. Sorry. So the first thing we have to do is actually make an if check. And the if check is going to check if the data pointer is, if whatever's in the data section, if that is true, then I think we just continue. Yeah, if that's true, we just continue. Otherwise, we're going to find the next bracket. we want to skip everything. So this is actually just, actually just gonna go ahead and keep moving forward. If if it's true there, and if it's false, then we will want to skip over. Then we'll want to skip over all the we want to skip over everything until we find the matching bracket. So this is just to move it. So at this point here, the instruction pointer would be at the opening brace. So this would just move it one ahead of that. And since we begin, we could just actually not do this. Here, we could actually leave this at 0 and leave this normally like this. And then inside of here, or no, we should start at 1 because we're checking if it's greater than 0. So we'll do that, and then we'll do plus 1. Okay, so now we're in the so if we're looking at this program here, we're right now here, and we're trying to find the closing brace. But if we find another opening brace, then we need to increase the number of open brackets we're keeping track of. So if program IP, program IP, if that's equal to bracket, the opening bracket, then we increment the open brackets list here. That's what we do. I think we use elif here. If the program is pointing at a closing bracket, then what we do is the open brackets, we just found a match, so we -1. And that's actually really it. Everything else we don't really care about. And we can just easily move to the next instruction. So let's quickly go through the logic here, and I'll make this a little bit smaller just so I can see a little bit more data. Hopefully everyone can see. Hopefully in the final video everyone will be able to see what I'm looking at. But basically, here we have open brace, and if whatever the data it's pointing at is that a non-zero, if that's a non-zero value, then we'll just increase the instruction pointer, and then this will just loop around and do whatever. If it's not, then we have to skip and find the matching closing brace. And so first we begin with the open brackets. We start at 1 because we just found one, and we increase the instruction pointer so it points to the code right after the open bracket. And then while the open brackets are greater than 0, we keep looping through the program until we find the close bracket. Now, it's totally possible to just do this through like a pre-processing stage, and then just have we could have a set of instructions, and the loop instruction would just have the location of how far to jump forward, pretty much. But since the program is so simple, I kind of just want to inline everything. And as I mentioned before, since I'll be trying to write brainfuck in brainfuck, I think inlining everything makes more sense. There's no functions in brainfuck. Everything is you have to just do, in vanilla brainfuck at least, you have to kind of just do everything inlined. And so yeah, okay, so that seems fine to me. Eventually, if we find the right closing brace, the matching one, this will be 0, and then it'll end. We'll add +1. So this, what'll happen is we'll hit this. So this is when the instruction pointer is at the close brace. Then we'll add 1. It'll be at 0 at that point, so this will fail, and then we'll just keep going, and then that's pretty much this the opening brace instruction. We don't need to do anything else for that. Now let's do a closing brace. So this one is sort of like the opposite way, wherein if we encounter it, we actually want to look backwards. And so we can do that. And this is actually, is there a not in Crystal? Actually, let me look at the conditions. Okay, perfect. So this is perfect. That's what I want. Oh, this is something crazy I totally forgot. If data pointer is greater than 0, or sorry, yeah, if it's greater than 0, then we just want to keep moving. we want to like dig into that brace. And here, if the data pointer is equal to 0, then we want to do something else. Or actually, if it's not equal to 0, if this is greater than 0, like this, and this is not equal to 0, because it could be negative. Whatever's at the data pointer could be negative. And I'm going to assume it can be for now. I'll check later with like a brainfuck interpreter whether that's true, and this is like a really easy change, but for now, it'll be, if it's non-zero, then it's a true value, and here, if it's non-zero, it's also, if it's 0, it's a true value, or it keeps going. So here we just want to do IP. So this is like if when you get to the closing brace, we just keep going because the data pointer is at 0, and that means we don't want to jump back. But if we do want to jump back, then we do something very similar to what we did with the opening loop thing. So let's do close brackets, and that'll be 1, and then we'll do IP -1 like that, because now we're moving backwards. And now while close brackets is 0, right at the end there, if program IP is equal to this the closing brace again. So if we're traveling back and we see another closing brace, then we know that the next open brace must be for, like, it doesn't match with ours. So let's make sure that we increment that value, and then elif. Now if the open this, so if we encounter one of these open brackets, then we want to subtract 1 from this, and we want to keep moving this backwards until we find it. And again, we're not going to do any error checking for now. For now, we're just going to assume that if there's a closing brace, there's a matching open brace. Okay, so I think that's actually it for now. I think we've implemented 1, 2, 3, 4, 5, 6, 7. Okay, so we've implemented 7 instructions. The only one we need is the only other instruction we need is the input instruction. For now, let's test out if even this works. Let's just be able to print A, and that would be pretty cool. Let's build breakfuck. Is it gonna just work? Oh right, yeah. Delete that. Call main, and let's see if we build. Undefined elif for top level. So that's on line 34. What was it, line 34? I'll fix that in a second. What? This is not a top level thing. It's because maybe I didn't end it, maybe? Undefined method elif. Maybe it's because it's not elif. Maybe it's because it just used a random ass keyword, else. Okay, my bad. But why would, okay, whatever. I think this looks way uglier. Like, doesn't this look way uglier than like just elif? All right. This has to be else if too. Okay. All right, moment of truth. Let's see if we print out A. And it didn't do anything. Why not? Okay. I guess what we'll do is, I mean, it should just do it. Let's do, I guess, some prints. Let's see what happens when we just print stuff. Okay, so interesting. It's like skipping stuff. It looks like it's skipping stuff. So let's go back here, and it's this. Okay, I think broke something. Let's see. Okay, whoops. Okay, so we have to delete this guy here. There we go. So that should now be fine. Okay, let's see. And we got an overflow exception because I have no idea. All right, well, let's see what went wrong. I'm going to main. Okay, so I'm increasing it too much. I'm increasing this one too much. I've gone... This DP is not pointing... I guess it's not pointing at the right place. So let's... Can I do this? Is there commas in here? Like, what happens if I do that? It prints it out in, like, on the second line. So let's... How about we just, for now... I'm gonna put the OP here. IP plus equals 1. And we're gonna continue. So that should just... Undefined locator continue? What do you use for continue? What's the like what do you do to skip to the next one? Next. Okay. Hopefully this doesn't give me like a compiler. That'd be really annoying. Okay, sweet. And now let's check this. All right, so that just works. And it didn't print a new line. That's so interesting. Oh, that's okay, because I'm doing print. Oh, that's so interesting. That's so interesting. Why is it... It's so weird. Why did it print out the entire thing? That's really weird. So put S does it, like, does what I expect. But print does something else. It's so interesting that it does that. That's really interesting. So I'm just not gonna use print because I don't get what it does, and there's no documentation on it apparently. So, all right, let's see what could possibly be going wrong. Like it all looks just fine to me. Like what? So basically what's happening, if we go to, man, I really need to take off that error thing. But if we go here, so this moves directly behind. So this moves right behind the opening brace, not at the opening brace, because what will happen is that this moves back one. And if this is the opening brace, then what will happen is that it'll find it, and then it'll -1 from it. And so we should do this before, I think, right? Like this. Should do this before, because the first iteration will skip over our closing brace, which is what we want, and then when we find our opening brace, we'll be on it. And I guess what we can do after that is when we come out of here, we could just IP plus 1 because we'll be on the opening brace, and we'll want to maybe start. But wait, okay, what does the documentation say? This is what we really need to check. If the byte is non-zero, then instead of moving the instruction forward to the next command, move it back to the command after. Okay, so it moves after. Okay, so if we go here, then we do need to add that plus 1, and that'll move it after the opening brace that we found. And that should be it. This could also be at the bottom here. Like it could be like this, and then it could also be down here. But I'm not gonna do that. I'm gonna put it up here. I think it makes more sense here. Okay, now it should print. It should print A, yes, or maybe like the byte representation of it, right? Let's see. Moment of truth. Nice, we print 65. Yay! Alright, so now let's go back here and take out all those debug prints. Okay, so we got that, and now what we need to do is we need to find a way to like just print one character. I just want to print the character on the screen. I just want to put it into std out. Like, how do I do that? Okay, let's do this. Let's do printf. Printf seems like the way to go. Like, it has a no new line, which is what I care about. All right, we're gonna do printf. And in Crystal, you don't need brackets to call functions, so this should just work, right? Hoping it just works. Reader. What did I do wrong now? Expected argument, reader needs to be string. Not yet. Oh, perfect, 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 perfect. How do I convert byte to character? Crystal. Just saw returns a char that has a Unicode self without checking this inches range value. Okay, so this one so unsafe character. I think that one's it. It's like, what's gonna happen if I do that? Unsaved char. All right. Compile. Compiles, and now if we run it, prints. All right, we got 8. Cool. Now we're going to add the input function. So I don't know how the input is supposed to work in Brainfuck, but I'm guessing it just takes standard, input, right? Read one character from enter into value at the pointer. What's input in? I guess it's get 1 byte. There's still input. Okay, here we go. Gets 1. Nice. That's what I wanted. Look up gets crystal docs. All right, let's check out gets. Okay, reads a line at the limit, at most limit bytes from this IO. Okay, so that's his bytes. Perfect. That's what I want. All right, so let's do that right now. Oops, that's not what I wanted. And then fuck. Okay. Oops. Okay. And we can finally implement the final when, which will be that get s1. And this will, what does this return? This returns the first, okay, this returns a string. And how do I put that into a byte? Can I do that? And then just do this? Is that a thing I can do? I guess to test it, I will. Let's change our little program here. We'll just copy this for now and comment it out. We will grab a character and then we'll simply print it. And hopefully that'll just work. So if I type something, I should just print it. Let's build it. Can't cast string. Right, it's because I'm getting a string. So how do I, like, what I could do is I could put this inside a variable. So let's call this the byte that I want, but I'm not going to call it that. I'm just going to call it, yeah, C, because it's going to be a character. In here, I will check if it's actually in there. And if it is, then I'll do something, which means converting it from a string, which means just getting the first character and putting it into, maybe this works. Like, maybe this works. Data p, and that should be equal to the pointer 2 should be equal to whatever is inside the first character of whatever string it returns, if it's actually returns something. And if it doesn't, then what we'll simply do is if it returns nil, then I guess nothing happens. We'll literally just end it there. We're gonna not print any errors yet. So we build that. Still can't cast car to Uint 8. Okay, perfect. So I think there's two. There's definitely a 2 U8 method I remember seeing. And I think it's just 2 U8. Maybe it's just that. Okay, cool. Alright, let's run it. So this would just print. So this would just wait for my input and just print it. Invalid integer G. Ordinal. Code point for this one. Okay, so let's try that. Let's try ord. Let's try ord. Let's try ord. Does that work? And actually, let me... Like, all this will be air checked a little bit better later. But for now, I just want it to work. I just want it to work. So now we'll build and run. Okay, so if I type G, perfect. We got it working exactly as specified in Wikipedia. Okay, what's next? Right, reading from a file. Let's do that. Reading from a file in Crystal Lang. I think we had an IO. Okay, someone's gonna say something. Cool. File content. Cool. We're just literally gonna read everything at once, I think. Yeah, just for now. Cool. Let's go back here. Oops. Brainfu. And let's do that. Okay, there we go. And now, man, the regular commands just do not work. Okay, so file content, and I think I want to get the command line arguments. Command line arguments, because it's kind of cool that it allows you to just do on that. Okay, let's just use it. Let's just use the option parser. That's what it wants us to do, and I guess that's what we're gonna do. Cool. All right. Require option parser. Okay, you won, Crystal. I'll use your option parser. Option parser parse. Oops. Parse. Do. I think this is like their block syntax. I know enough about Crystal to know what's happening here. This is kind of like a it's very similar to like a lambda. And this is kind of like the parameter for it. It's not actually a lambda. It's like they call it block, like a block, and it's a very powerful construct in the language. But I'm not gonna focus too much on like what it actually does and what it actually is, and like how powerful this block, and just pretty much just copy and paste what I need to copy and paste to make this work. But yeah. So that's that option parser, and so you can do like a banner. I'm not gonna do that. I'm just gonna do parser dot on, and I'm gonna do. I kind of wanted to input like a. I kind of want a file. Like I wanted to let me put in a file. Okay, so I think we have to do this. Name, and then it's crazy that this just works like this. It's really it's like really it's really intense. Like if this is how you specify, like you use a string in here to say like this is like kind of crazy actually. Or is it always name? Like is this always, I guess we'll find out. So we'll copy this guy and we will paste it in here, boom, and that should just be fine. I'm gonna actually not even run main. I'm gonna do this near at the bottom here. Okay, so this would just like it should tell me that this is the option. So just compile it and see if that works. Cool. And now this. So it doesn't do anything. H? No. Invalid option. Okay. So it doesn't show me that. What about T? Oh. What about... Nope. Interesting. So that didn't do shit. Okay, so it just sets the destination name. Okay. So let's put S. Okay. Oh, okay, there we go. And then Brainfu-T hello world. Okay, all right, so that's how we get the file name. Oh, jeez. All right. So we open this guy back up, and now we can move this bad boy all the way to the top, like just like here. Give it a nice little indent, and instead of name and all this stuff, all this is just gonna be. What if I change this to? Oh, okay, well now I want to play around with it a little bit more. So let's move this back out here. Oops. Okay. So instead of name, I'm gonna make this path. And I kind of want to see if, like, this just. That'd be nuts if this just, like, it just works like this. That'd be really nuts if it just works like this. Seriously. Also, why are these... What's going on here? Okay. That'd be nuts. Okay, so... Will this just work? That's crazy that it does that. I wonder how that works in the back end. Like, how does it know... Like, how does this on function know that this is, like... Like, how does it know? Oh, well. What if I just do that? Like, do I need this option? Like, what if I just do this? Can I just delete this? Am I allowed to do this? Path to source. Is this a possible thing to do? This is legal. Okay, so it compiles and then... No, it doesn't like that. It doesn't like that. So... Probably does some like code generation, right? That's probably what it does. Like it has some really Chris has some really powerful macro stuff. So I'm assuming that's what it does. So I'm just gonna do I guess dash o. I don't know how else. I'll figure out how to better do this later. Path source. Let's build it, and let's just print whatever I type in. Okay, didn't like that either. So do I need... Alright, how do you... Dash home. Okay, so do you need all three every single time? Is that the thing? You need all three. No, here's salute. Interesting that it does that. It's interesting. It's like a very interesting way of doing command line arguments, because it seems useful. It's just that like if you want something very simple, it's not necessary at all. Because like puts parser. Oh, show this help. So if you print the parser, it just shows this. Interesting. Cool. Alright, so let's... Why doesn't this work? I just did this, didn't I? Maybe it's because I'm doing too much. So that's dash O. Alright, I'll just do another one. Like that, I guess doesn't like it that it I keep it to 0. I guess it doesn't like that I don't have all three that. So that compiles just fine, hopefully. And then what did I do to change this? Invalid option dash T. Oh, okay. My bad. Oh, okay. So now let's go back here. Just had the wrong option. Let's go back here and delete this guy. I don't want this. Does this work? Dash O. Perfect. Man, I really wish I could just get rid of the dash O, but I'll figure that out later. All right. Let's go back in here, and now we can finally put this inside our main function. Get that there. In here, we'll put in path, right? And then here, instead of this, we do path. If not path, how do we? No file. Okay. And then what do we do here? Let's return, right? I guess I could just return here. Doesn't matter. Done. And then I can do that, and I can do this, and I can do this. Program, program, and let's move this guy down here. And I feel like I can just delete that, close this, and get a new brainfuck file. Let's do hello.pf. This will be hello. This one will be. But for now, we will do our typical print A. So, or actually for now, let's just do let's do print A. 1, 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5. So that's 15, 30, 45, 60, 45, 65. That should print A. Okay, and now let's build it. Still should have a way to just build and run, right? Whatever. Crystal CR. And now moment of truth. Brainfuck dash O. I guess it should be dash I. Because this is like an output. I don't know why I did dash O. And let's do what was the file? Oh, yeah. Nothing happens. Great. I'm not running main. It is just not liking that I'm not running main. Put that at the top. And I think some computers have an issue with not ending any line. So we'll do that. Build. Undefined local variable for top level. Not path. Why is it put no file to compile? Oh, because I didn't even... First of all, path. File. Does this just work? That'd be really cool. Path equals. Okay. Build. Unexpected token equals. Really? Oh. Path. Cool. Oh no. Path or string, not path or null. Okay, that's a good point. But it's interesting that it doesn't catch, because from what I thought is that Crystal would catch this as being like path would be available here. Because here we found out that it's empty, and therefore in the else, like down here, it should be like the flow typing should tell me that it's like the whole thing with Crystal is that it's flow typed, and so this should be So at this point it should be not nil because we just checked it. And so I kind of wanna see why that doesn't work. Crystal programming language. How am I supposed to? How do I do? I think there's, yeah, the conditionals should help me. Conditionals or crystal. This should help me, and the reason is because it should flow type it. Like everything after, yeah, like everything after, uh, that if should be fine. Um, Maybe there's like an is. I know there's some examples. There's some examples in like right on the website here. Like if we go to welcome, where's the, like the front page of Crystal? Like if we go here, like it has a bunch of examples. And I remember seeing here like here it's showing you here that like, hey, like you need to have it defined, concurrency model, C bindings, dependencies. Okay, so it doesn't show it here. But there's a place where it shows like where like it shows you, where's the specification? Like it shows you that you can control expressions, maybe, if it shows you that you can like do null checking like this. Because you see here, like it shows you that like, hey, you can set B as 1. And if you do some condition, then down here B is like some like it's a union of these two. Um yeah. And so at this point here, and see how it shows that it's like here it's still an integer, E is an integer because this, like, it's either one or the other, and because there's a return in here, it'll only ever get down here if this is false. And therefore if this is, sorry, if this is true, it'll skip over this else, and no matter what, this will be an integer. And so there's something we can do, maybe this, if this. Here it is nil because it's on this branch. Here nil is because it's falsely validating this branch. Yeah. And if var. I thought it would also do it after. That's the thing. Like I thought it would do it after. Can't be nil in there. Is there a way to just, okay, so I think is a var is a string. It's a number. Like, do you need an else? Like here it's very clearly like returning. I'm just gonna do isa here and see if that works. Isa. Is it nil? Yeah, it doesn't like it. It really doesn't like it. Which is weird. Um how do I force it? How do I force it then? To be yeah, I guess I could, like down here. Like I'll just force it to be a string. Like I know it's supposed to be a string. Like I know it is. So yeah, that should go just fine. And I think we typed in, what was it? It was A. So let's go here. Uh-oh. Parser. Oh, it's because, okay, so nothing happens. Great. Great. Nothing happened. And print the program at least. Oh, maybe it's because, did we do anything to, did we do anything? Yeah, no, it should be fine. So here it prints the path, prints the program. That should be fine. Why doesn't it print what I want it to print? So let's build it. Oh, we're so close. We're so close. So weird. So it's kind of stuck here. It means it's probably doing like some infinite loop that I haven't caught for some reason. But there's only pluses and a dot, and so really, where could this be happening? Maybe it's just not catching. Like maybe the no, this is fine. Like all this is pretty good. Ah, yeah. I forgot that I'm putting in. For now, I'll take this off because it shouldn't. But why is it not? So that's fine. Here's adding one. All these are adding one. So I'm guessing that the OP is not what it expects. So let's try just printing it out. I'm just gonna print F here and see what happens. I guess I will also. I could just do this. And I can put this in here, and I can put OP in here. And put a new line. Okay. Interesting. So it's showing that it's getting like a space. Is there a way, like when I print this out, read file as ASCII crystal. Let's read a file. Okay, we just did this. Gets to end. Interesting. No, this should be fine. Do that. Right. And I'll also do this. So let's build it. Here. Okay, so it's really not liking something. It's really not liking. It's really not liking. Is there anything that prints in the beginning? No. Okay, so how do I get this string by? It is printing the file though, which is nice. I guess it also might be like looking at that new, but it should just skip over. No, it shouldn't. It shouldn't. So if we get a different character, like if there's anything else, we're just gonna move forward we're gonna move forward the instruction pointer. See, that works because there's probably a new line in there somewhere. And there's probably other random shit. Okay, so it works. Cool. Wow, it works. But there's random spaces. Oh, it's the new line. It's the new line character. Yeah, it's the new line character. That's why. So it just kind of kept going in the loop because it didn't know what to do with new line character. But there's the A. And now if we go back here, let's make sure to take this off and compile it again. And then the next thing we're gonna do is finally write hello world in Brainfuck. And then we'll be done. That'll be what I'm doing this stream. And next stream I will be implementing the native version of this. So I'm gonna set up my computer to, allow for syntax highlighting and figuring out how to do those things. And then I'm also going to try to write it in x86 64 assembly. Try to get into like a native version. But yeah. So right now everything was kind of messed up just because of the first stream. But I feel like I sort of had to like give this a shot to know what's been wrong. So yeah, let's see. Hello.brainfuck, and let's now finally fuck. Cool. So that does it perfectly. All right, now we can finally go ahead and write our hello world program in Brainfuck. Okay, so if we've done everything right, and it looks crazy, this is the hello world program for Brainfuck. It looks crazy, but if we've did it correctly, it should print hello world in all capitals, and then we'll be done. Okay. So, moment of truth, hello world. And that is pretty much it for this stream. I guess the next thing we're going to worry about next stream is we're going to add air handling, add some syntax highlighting so we can see, and hopefully we'll be able to compile to native. I've never compiled anything to native ever, and so like I've never written my own, well, I have like in university a little bit, but I've never done anything past that. So it'll be kind of cool making Brainfuck compile to native code. I think it'll be really cool to do in Crystal. And I think there's a lot of cool things Crystal does. I just, just kind of wanted to get used to it by writing a simple program now. So, yeah. Anyways, thank you for watching. Check out the description for anything that was missed. And yeah, that's pretty much it. Thank you guys.